Hello, algebra students. Mr. Lawrence here with your flipped lesson, and should be pretty much review. I know some of you have some holes in your learn, so we're going to try to close those holes. We're going to talk about adding and subtracting fractions. Now, why are we doing this? Because when we do some problems that have fractions and variables in them, like this, they are really easy problems if you understand how fractions work. But if you don't understand how fractions work, oh, this problem is a nightmare. So we're going to go ahead and spend a couple of days doing that before we start getting into the real meaty part of algebra. All right, now, you see this problem number one here, 1/7 and 4/7. Now, I don't know if you ever realized this, but let's take a step back and let's talk about this. That's 3x, correct? What does that mean? Doesn't that mean that there are 3 x's, right? Isn't the multiplication like a quicker way of saying, hey, there's 3 of whatever this is, right? This would mean that there are 10 y's, right? 10 y's being added together. When I have this, I'm telling myself I have 1/7. So if I have 5/7, that's really the same as 5 of the 1/7. You see, the fraction behaves very much like a variable. It's not a variable because we know its value, but the way they behave are the same thing. That's what this means. So let's go back and take a look at this problem here. I have 1/7, and then I have 4 more sevenths. Well, duh, I have 5/7. Of course, it's that simple. But sometimes we miss the simplicity in trying to memorize all the rules. Now, when you look at problem number 2, it, it doesn't look as simple as problem number 1 because I'm talking about eighths and I'm also talking about fourths. Well, if I could figure out a way to make those denominators match, the common denominator you've probably heard about. Hold on a second, my screen just went blank and I think it's coming back. Okay, good. All right. If I could figure out a way to make those denominators match, then I could just count how many eighths or fourths I have, whichever the case was. Now, the common denominator is going to have to be a number that both denominators go into. And if you like, you can write it out. Like I'm going to take the larger denominator, which is 8, and I'm going to count by 8 until I get a number that the other denominator, 4 in this case, goes into. And I'm going to yell stop when I get there. Okay, you ready? 8. Stop! Yeah, 4 goes into 8, doesn't it? My common denominator is going to be 8. So, how can I turn this 4 into an 8? Well, I could multiply it by 2. But if I multiply the denominator by 2, all of a sudden I've changed 1/4 to 1/8. That's no good. I'm going to actually multiply the numerator by 2. So I'm not going to multiply by 2. I'm going to multiply by 2/2. And if you're pretty sharp, and I know you are, what is 2/2 the same as? It's the same as 1, isn't it? Yeah. So you see, I'm only multiplying by 1. What happens when I multiply by 1? Nothing. So I'm going to multiply by 2/2, which is a special form of 1. And I'm going to change the way 1/4 looks, but I'm not changing its value because I'm multiplying by a form of 1. So I'm not going to do anything to this first fraction because its denominator is already 8. So I have 3/8, and let's see, 1 times 2 is 2, and 4 times 2 is 8, and now I have 2/8. Well, if I have 3/8, 1/8, 1/8, 1/8, and I have 2 more eighths, 1/8, 1/8. How many eighths do I have altogether? Well, I must have 5/8. See, fractions are really simple. The problem is we get bogged down in memorizing all these rules and we don't understand what we're talking about. Okay, let's try one that looks a little bit harder. I've got 3/5 and 7/9. So I'm going to take the larger denominator and I'm going to count by it until I get a number that the smaller denominator goes into evenly. All right, so I'm going to count by 9s. I'm going to get 9, 18, 27, 36, 45. Stop! There we go, 45. 9 goes into 45, 5 goes into 45. My common denominator is 45. So how am I going to change 5 into 45? Well, I'm going to multiply by 9. But I'm also going to do it in the numerator. Look at that, I'm multiplying by a very special form of 1. Turning this fraction into 27, 9 times 3, over 45. So I have 27 45ths. Don't worry, I'm not going to write them all out. Now, for the ninths, that's not 45ths. So I've got to figure out what to do to 9 to turn into 45. In this case, I'll multiply it by 5. And I'm going to multiply by 5 over 5, another special form of 1. 7 times 5 is 35. And 9 times 5 is 45. And if I add those together, I think I'm going to get 62 45ths. Now I should look to see if this simplifies, but I don't believe it does. I'm just checking really quick. 3 doesn't go into 62. 15 won't go in. No, I think this is good. All right. Now, if you don't like the mixed number, you can say how many times does 45 go into 62? Well, once. It would be, what, 17 short of 62, I believe. And then I divide by 45. So you could give me that as an answer. Please don't run to a calculator on these. Either one of these are answers. They're synonymous. They mean the same thing. All right, what are we going to do when it's subtraction? Well, I'm going to suggest this. I'm going to suggest you do it this way. Take that negative and assign it to the 1, okay? Because I don't know if you realize this, but if I have negative 1/5, that's the same as negative 1 over 5, and it's also the same as 1 over negative 5. Here, I'll prove it to you. Let's say I have negative 20 over 2. 20 divided by 2 is 10, but it's negative, right? What happens if I have negative 20 divided by 2? Well, that would be negative 10, wouldn't it? If I owe $20 to 2 different people, meaning I owe equal amounts of money. Let's say I borrowed money off of Jose and Natalie. All right, I borrowed money off of them, and I owe them a total of $20, and I borrowed the same amount. Well, I know I owe each one $10, okay? Now, if I have 20 divided by negative 2, that's still going to be negative 10, isn't it? So you see, it doesn't matter if that negative is in front of the fraction, in the numerator or denominator. It is very unusual to see this one. This one is unusual. Most mathematicians don't like it. You won't see me use it much. These two are much more common. So for for taking care of my fractions, pardon me a second, something opened up that I didn't want. I like to take that negative and reassign it to the numerator. Okay, so now I'm going to count by the larger of the 2 denominators, which in this case is 7. 7, 14, 21, stop! Okay, 21 is my common denominator. I'll turn 7 into 21, but I have to do it in the numerator. Look at that, 3 over 3, a special form of 1. And over here, I'm going to multiply by 7, like that, 7 over 7 technically. And I will get 3 times 4, which is 12 21sts. And I want to take away 7 21sts. Well, 12 minus 7 is, so I have a middle blank, it's 5, of course, 5 21sts. Okay, there you go. See how simple fractions are? This is really easy stuff. Okay, now let's look at this one. If I have 1/10 minus 1/4, well, I'm going to count by the larger denominator. 10, 20, stop! Oh, 20 is my common denominator. 4 goes into 20, 10 goes into 20. So I'm going to multiply this by 2 over 2, like so. And I'm going to do this by 5. And all I'm doing is multiplying by a special form of 1. It changes the way my fractions look, but it doesn't change their value. Okay, so this will be 2 20ths. And then I'm going to assign that negative there. And I have negative 5 20ths. Now, some of you are going to get this wrong, so I'm not going to write the numerator in yet. But let's say I had the problem 5 minus 2. That would be 3, right? Okay. But the question is, what's 2 minus 5? Well, let's try this. 10 minus 9 is 1. 9 minus 10. What if I had... Do you know why this is 1? It's because there's 10 positives. And then there's 9 negatives. Okay, and some of them cancel. These two cancel with those two cancel with those two cancel with those two with those two, this one with this one. What's left? 1 positive. What would happen in this situation? Well, I'm going to have 9 positives, and I'm going to have 10 negatives, right? And I'm going to say those will cancel, those will cancel, those will cancel, those will cancel, and these will cancel. I'm left with this. It's 1, but it's negative. So 9 minus 10 must be negative 1. Now notice the 10 was positive and the 9 was negative. Okay. In this case, the 9 was positive and the 10 was negative. I get the same answer with the inverse sign because the negative number is larger than the, or has a greater absolute value, I should say, than the positive number. So when I do 5 minus 2, 5 has the greater absolute value. It's a positive. My answer's positive 3. In this one, 2 minus 5, I'm still going to get 3, but this one has the greater absolute value. And so it's going to be a negative 3. So my answer is going to be negative 3/20ths, or you could say it as negative 3/20ths. They're the same answer. Now I just want to spend a minute just practicing a couple of those real quick in case you have a hole in your learning. 3 minus 7, 6 minus 10, and I don't know, 20 minus 30. Okay, so the signs are different. One of the numbers is positive, one of the numbers is negative. I'm going to subtract the smaller digit from the larger digit, but then I'm going to take the sign of the larger digit, the one with the greater absolute value. So 7 minus 3 is 4, but the 7 is negative, so it's negative 4. 10 minus 6 is 4, but the 10 is larger. Boom, it's negative. 20 minus 30, well, 30 minus 20 is 10. The 30 is larger, it's negative. Okay, why don't you try these couple of problems here. And go ahead and pause the video when you're ready to see my solution. Let me know. All right, 15 minus 12, well, that's 3. The 15 has the greater absolute value. It's positive 3. Okay, 11 minus 9 is 2. 11 has the greater absolute value. It's a negative. It must be negative 2. I got a 20 and a 7. The 20 is negative. 20 minus 7 is 13. The 20 has the greater absolute value. It's negative 13. There you go. All right, that's your video for tonight. Have a good night, everybody. Mr. Lawrence signing off.